Hello. Uh, hello everyone. Basically today we're going to talk about roots and surds. And first of all, you have to understand the stuff about rational numbers. So basically, rational numbers can be written. Rational numbers are numbers that can be written as fractions. For example, basically, how can I explain to you? So I mean, any kind of literally like 99% can be written as fractions. But for example, pi can't. You might be, oh well, pi is a term. Okay, square root 2. Because like there's so much. Pardon me. Because there's so much decimals, it can't be. For example, we can do 60. Okay, 67. That can be written as a fraction like this. So like for example, A can be 5 and B can be 10, right? Or like even 0 can be is a rational number. However, like B cannot be 0. That's the thing to understand, that the what's it called, the denominator can't be 0. And also I just realized I don't know oh, sorry for TikTok. I just realized that I don't quite understand what is integer. What's an integer? An integer is a whole number. Oh, yeah, I am dumb. And the integer is a whole number, guys. Okay, now let's start. So first of all, let's know that kind of the rules that, for example, these two times each like are basically the laws of roots and surds. This is surds, yeah. This is equal to this, so both numbers being together. And then the other law is this. I mean, it's kind of like, basic, I guess. But yeah, that's kind of the thing. So, and let's just crack on with the questions. So question 1 is, we're going to go through the basics, of course. So we are able to split kind of this into two numbers. So, but they also have to be all rooted. So this can be split into 2 and 4. And when you split it, you have to make a number that is a square number. For example, 4 is a square number, so we're able to split it like this. You don't need, I assume sometimes you can get two square numbers, but you will need the square number so it becomes an actual full number. So as we can see here, we know that square 4 is basically 2. So our end result of the answer would be this, right? But in real life, it would be this. Like in the exam, write it like this. And wait, what was my thing that I was confused about? Yeah. And then, never mind. Wait, but like, yeah, no. And then same with 12. So for example, we know 4 is 1 already. So we're just going to do this, and our end result is just straight away going to be this. So pretty common if you ask me. And let's say you have something like this, right? What you do, just times these numbers, guys, like, bro, and just put them under root. So 36, and then you find, you look for a square number that creates 36. And for 36, that will be 6. So that's the answer. And then, let's say we have this, right? We, from the laws, we know that that is equal to this. And we know that these two divide in each other. That gives 9, square root of 9, and that equals 3. Hey, what do you mean it's wrong? Yeah, no. After that, let's say we have square root of 28 plus square root of 63. We have to again split these two. So I'll split this. So this into 7, 14, 21, 28 into 4 and 7, and then I'll split this into 9 and 7, and so we'll get 2 seventh plus 3 seventh, and so we are able to just put 5 seventh. It's pretty like easy. And now comes the A-level part. Okay, so this is like the A-level theory part. So also before, I mean, basically first about the algebra with surds. So the first question is this. So as we already like, basically it's just gonna be this, and this equals 2. So yeah, but also easy way to think about it is the laws of indices. So we know that what is it? Okay, so let's say square root is basically equals to 1/2, right? Like if there's a number and it's 2 1/2, that means it's square rooted. So we're able just to put 1/2 times 1/2, and when we add the, basically 1/2 is like 0.5, so 0.5 is basically, it just becomes actual 1. It's kind of that, I think, like, I think you should get it. It's pretty, then let's say we have something like this. Well, it's just gonna be 6. So yeah, there's nothing really crazy about it. And then now let's talk about rationalizing denominators. Rationalizing denominators. So let's say we have something like this, right? I'm not sure exactly what we're doing. However, to answer this question, I guess, like, I'm not even really, okay, basically I assume that most of the time we don't want the denominator on as a to be root. So that's basically, yeah, I think that's the case with rationalizing denominators. I don't know what rationalizing means. Okay, actually, let me ask ChatGPT, but I assume it's about not making the denominator the same. What is rationalizing hey, why do we rationalize denominators? Like, let's say like, I do know how to do it. Like, I just studied it, but I don't understand what exactly is it. Like, let's say, how do I guess the question will tell me what to do, but like, for example, right now I just have a 2 over rooted 3. Like, how you know, like, what do I want as an end result, if that makes sense? Like, how do I notice if I need to use rational denominator method?
Let me just check that. That's a really good question. The point of rationalizing the denominator is just to get rid of any square roots on the bottom of a fraction. For example, if you have 2 over square root of 3, you multiply the top.
Did you just hear what she said? That was exactly what I said, literally. And I didn't even know. Okay, anyway. So to do rationalizing, we just have to times the thingy-majiggy by whatever on the bottom. So, 3 to get rid of the, yeah. And so, we get this as a end result. And, yeah, and also, if you think, oh, but won't, like, this change, like, this can't be equal to this, you, like, times it. Guys, you see the fact that these two numbers, they're exactly the same. Like, whatever you put here has to be over here. And you know what happens when you divide something that's equal to the other thing? This is equal to 1, and you're times in it. Whatever you times by 1 is equal to the same, like, it doesn't change. So you're safe. Don't worry. Now, with two denominators. So, let's say we have this now, right? What we do now is we have to times with the opposite, like, sign, like, right? Also, you know what I want to ask? Like, what? Now I said that we have to change the sign. I want to ask if, let's say, yeah. Okay, I get that, but so let's say I have to rationalize a denominator, and that, like, it has two denominators. So for example, 2 over 5 plus rooted 3. So I have to, like, change the sign, because, like, it's 5 plus the rooted 3. So I times it by 5 minus rooted 3 over 5 minus rooted 3. However, what would I do if the minus was negative? So let's say it was negative 5 plus rooted 3. Would I times it with a positive 5, or would I just keep, like, whatever is not the root, would I keep it the same, or do I change every single sign in that equation?
Let me check that. Yeah, that's a great question. You only change the sign between the two terms. You don't change the sign in front of the 5. For example, if you have 2 over minus 5 plus root 3, you multiply
yes,
by
I get
minus 5 minus root 3. The minus 5 stays minus 5. You just flip the sign between the terms. You're doing it right.
Okay, but let's say the denominators have more than 3 times. So let's say it was okay, let's say it was positive 5 plus square root of 3 negative, or take away another 5.
Well, let me check. That's a great question. Once there are more than 2 terms, that flip the sign trick usually doesn't work, because you need exactly 2 terms to use the conjugate method. So if your denominator has 3 terms, usually you simplify first before doing anything else. Can you tell me?
Okay, nice to know. And basically after this we have to times everything by the stuff. So, okay. Let's go. 2 times 5, 10. 2 times negative this root of 3 is going to be negative 2 root of 3. After that, 5 times 5 is 25. After that, 5, basically this. And then plus 5 root of 3. And then root of 3 times negative root of 3 is going to be negative 3. And then because these two are exactly the same but with different signs, they just cancel out. So we have 10, negative this, and these two take away each other, 22. We have this left. And after that, we're able to divide it by 2 because, pardon me, all of these are in a 2 times table. So that would be 5. And we can put 1, but we don't need to because these two, they times each other right now. And the 1 doesn't make a difference, so... Okay, why am I going messy again? I wanted to be neat in this video. Oh. So... Now... How much pages? I'm just... Yo... Okay... Well... Well... Yeah, this is going to be fun, isn't it? Okay... Turns out that wasn't even the start. So... A... Simplify 12 rooted plus 2, 12 rooted negative 2, B, express 12 in form M3, where M is an integer. Okay, here are the A-level maths questions, which are actually like genuinely are kind of easy, like, but of course, never mind, crack on. So simplify this, let's go. So to simplify it, we just like have to work it out. So this times this is a positive, it's just a 12. This times this is negative 2 square rooted 2. This times this is plus 2, 12. And then this time this is negative 2. These cancel. And so we're left with 10. That's not, it's not, it doesn't equal 2, it equals 4. And then says 8. Yeah, now that's right. After that, express 12 this in a form. So look, when it says like express this in a form and M is an integer, most, like, I assume most of the times it will say integer because what else can, I mean, like, I don't know. But basically we have to think of a number that, technically speaking, times this, so basically M times this gives us 12, technically speaking. So yeah, but that number has to be full. Oh, that was actually a very good explanation. M times, yeah. Like, don't forget about the root. Like, imagine the root wasn't here. What number would create 12, right? So 4. And so let's just write this, because these two do equals this, but we can't have the square root. So 2, 3, done. That's the answer. Next question. So n equals 2, basically. Okay. Okay, so it is given that x equals root 3 and y equals root of 12. Find in the simplest form the value of, the value of all of these. So technically speaking, we just replace what we know, like the worth of them. So for the first one, it is going to be this times this. That's equal 36, and that's equal to 6. I'll check the answers later. And then 12 root of 3 is equal to root of 4, and that's equal to 2. And then plus 12 in square, so 3 plus 12. That does seem right, but like I know that isn't right because I remember the answer for this one. Okay, first what we have to do, even though I don't quite understand why, but I guess first of all we have to simplify this as much as possible, and to do that we have to make this 4, this 3, because again we need the square number, we need the 2, so the end result would look so this, right? And then that would go into this. And that does seem very confusing. However, look, basically, remember, okay, not kind of remember, but each thing over here basically like has a 1 with it. So you know how each number has an invisible power? Kind of think of it like this. So there's a 1 here all the time, right? Kind of think of it, because it is a term, it has a 1 with it, like a guardian angel, I guess. And because of this, we're able to add it into 3, and the 2 just disappears. Well, everyone else probably understands, but I genuinely got confused so with it. Like when I saw the two missing, I was like, wait, how? But also, just an easy explanation of this is basically they're the exact same terms. There's two of these and one of this. Both times, it's like the apples. You have two apples, one apple, three apples. Done. I don't know why I just started talking about guardian angels. Like, that was mad. And so, we put it into brackets. Again, don't forget about the brackets because I just did. So this squared, 9, and then 3. These two times equals 27. So that's the answer for all of those three. Okay, so express 45 in its form and 5 where and it's the integer. It's an integer. Okay, that's easy. Basically, again, this can be 9. So basically, the 45 becomes square root of 9 and square root of 5. This becomes a 3, and so n equals 3. Easy, done. Yeah. Solve that equation. Okay, let me just double write it down. Giving your answer in simplest form. Basically, let's just straight away write this as 3 over 5. And then let's make this have a 5 with it. So, 4, we can do this. So, 2, 5 equals 5, take away 3 5s. So, this basically can go as this, because 7 take away 3, and this, by the way, times. After that, these can simplify. Like, not exactly simplify, but like, we can ignore them because they're exactly the same. So, let's say if we remove them from the answer right now, like, whatever answer we get, we can add them back because they're both there, if that makes sense. So 2x is equals 4, so x equals 2. my laptop, iPad is hot. And find x. It does say the hypotenuse has length of blah 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 blah. However, I don't think, I don't want to waste my time writing all that because all the information is right here, guys. Okay, express this in express express this okay, like, I guess cheers, mate. Express this into this, basically like last time, right? But this time we have to what rational denominator, right? Over here there's a thingamajiggy we have to get rid of. So yeah, okay, just solve it, mate. So we have to get rid of it, so we times the whole thing by 3 plus 7, 3 plus 7, and here comes the long maths. So 5 times 3, 15. 5 times rational 7 is positive 5 rational 7. After that, rational 7 times 3 equals plus rational 7. And then rational 7 equals 7. Then 3 times 3 is 9. Then 3 times the thingy magic is going to be rational 7 positive. Then this is going to be a rational 7. Then 7, negative 7 times, basically negative 7. These cancel out. And we have 2 left here. And over here we get 8 sevenths. And then 22 plus. And then we divide this by 2. 11 fourth 7. And as you can see, we have the same exact thing that we have here. So n is 4 and n is 11. Now here, over here we can just use Pythagorean theory. So basically AB plus equals C. However, we still have to, like, simplify them or whatever. Like, kind of work that way. No! Shoot, my pen just... Where did that go? Oh, there it is. Basically, the lid of my pen just left the chat. But it's back. So basically, we have 3 plus x squared equals 2/5 squared, and we can put it in brackets. And so 9, 18 x, so that would be 2 x's, right? No, they just leave it like that. And then 4, 5, so 20. And so this, take away 20, so x squared equals 2. And x squared is same as 2x, so x equals 1. Wait. Wait. There's no number that times itself to get a 2. Like, you can't, like, square root of 2 is a big number, basically. I said that at the start. So I'm very confused with that guy. Why did he get, like, the 2? I'm pretty sure there was... Oh. Let's find out.
Hey guys, welcome to part 2 of my video on surds. In this video, we're going to run you through the common styles of exam questions that can come up. This includes multiplying and simplifying surds, rationalizing 2 term denominators, and rationalizing the denominator. 3 lots of root 7, that's 8 lots of root 7 in our numerator. 7 plus is nothing. Then we'd have 18 plus x squared would equal 5. 4 times 5 would be 20, so that will equal 20. Meaning we'd have x squared would equal 2. So x could equal root 2 or minus root 2, but...
Oh, he said minus, like rooted 2s. Yeah, I have to include that in my notes. So it can be either minus rooted 2 or positive, or without the root. Oh, no, or positive 2. But with a root. And he said there's, like, it would be done for it being negative because, like, it's the type of the question, right? Like, what do you mean negative in a flipping triangle? So it's the positive, but it could be a negative as always. I mean, can't be, but, like, Okay, and the last question. Last questions, near there. Nearly there. Okay, so here's another question. This one is, just let's go. So this times by 2, 3, negative 5. And let's just do it like this. So 11 times 22. No, wait. Yeah. 22 and then the 3, so that's 66. So that was just here. And then now this. So 11. Oh, what would that be? Would that be negative 15? Yeah, it would be. Huh. And then, so, negative 11, 15. Oh, it would, yeah. And then, this times this. So, plus 4, 15. And then this times this, 9. 2 tenths. I'm confused because the guy, he doesn't have a 2 before the 10. Or it was probably just me not seeing that he did.
2 lots of root 50.
Okay, yeah, he doesn't have a 10. I'm curious why he doesn't have a 2 in front of the 10. Oh, I know. Basically, look. So you see, it's not 10 because they're the same. It cancels out to a 5, and 5 times 2 is 10. So it goes into a 10. Yeah. After that, this times this, 4, 3, so 12. This times this. Yo, what is that? That's 5. Negative 3 15th, and then over here plus. Oh, why the hell did I put a 3? It's a 2. Plus 2 15th, and then this times this, and then this times negative 5. Yeah, and then these two cancel, so we have this left, as if like that's gonna be 7. Yeah, and then we have to simplify all of this top mess. So take away 10 from this 56, and then negative 7 from this, and then this and this, basically this. And so we're able to divide this whole thing apart from this by 7. So 8, take away 15th, so the m is 8. Remember, our mission was to find m in the form m equals negative 5, 15. I also, yeah, like the fact that they actually kind of give you the answers, like, chill. And then just quick, so we understand everything, because like I got confused with this question after watching that, like the hard video. I went on an easy video and this got me confused. Mate, you just kind of, so these two times each other, right? So you can just kind of split it, divide the stuff, So this is going to be 5, and then this is going to be 3, and yeah, that's the answer. And then here's another right, square root 7, 3, take away 63 in form A7, where A is an integer. So this is basically easy. So look, times 7 times from this, so these become a 7, but this one gets left out and it stays the same. Then we need another 7, like, you know, for the final answer. So we get this 7, so this can be 9 and 7. This is a 3. What? This is a 7, this is a 3. And so 3 negative 7 take away 3 is 4, negative 7. So the A is equal to 4. Thanks, that's all. Goodbye. Oi, no, goodbye.